Okay, hello everybody. This is Hando here again. And today I thought it'll be worth our while to actually talk about distance formula today. It is a study that is part of coordinate geometry. This can be applied to, of course, for year 10 and year 11 math students who might be undertaking a unit in their maths course to study coordinate geometry. The reason for this lesson is not to talk about or it is to talk about how this formula works, but it isn't just to introduce this formula to you. It is to introduce how you should approach your studies all the time, right, in maths. And the idea is of understanding. So, what does understanding mean? Understanding is actually quite important because it isn't because you memorize your mathematical, concepts that you're able to do those questions. I mean, just simply think back to kindergarten times when you learned about addition, subtraction, division, and multiplication. Did you actually go home and, for example, in addition, learn every single possibilities of addition out there? Did you go home and got a little table out where you wrote 6 plus 3 is equal to 9, 6 plus 2 is equal to 8, 6 plus 1 is equal to 7? I mean, this sounds ridiculous, and I've only written it 3 times. It's really ridiculous how many there will be in combination of the plus and minus. So it's actually quite important that you understand these concepts because it's because you have understood it when you're in kindergarten or even in year 1 or 2 in primary school, that you are able to do division and multiplication, even subtraction and addition, without even memorizing every single sequence. You understand the concept of it, therefore you can apply it. That should be the case for every little thing that you learn in year 11 and in year 12. Okay, so distance formula is like another one of those. So just like we learn multiplication and division from the theory of addition and subtraction because they're directly related to each other, you can actually branch out the understanding of addition and subtraction and lead it onto the actual theory of division and multiplication. Likewise, distance formula just looks just like that, in that it actually comes from the theory of Pythagoras theorem. And if you see that it comes from Pythagoras theorem, you no longer have to memorize this formula here. Sure, you can write this down on your cheat sheet, and sure, you can memorize it, and it'll just work as well for you. But do you know how many formulas you have to memorize for year 11 and year 12? Trust me, your brain is not going to have enough space for all those information. And sooner or later, it actually helps for you to clear up some space and basically understand these things rather than memorize them, and just branch out a single piece of information into such astronomical amounts of information. And that is what it takes for you to score that 20 out of 20 and get that A plus for your maths subjects. So, I mean, if you know that it comes from Pythagoras theorem, great. But then, even if you know it comes from Pythagoras theorem and you can't generate, not remember, but generate this formula yourself, then I'd say you are not heading down a pleasant path. And if you don't make that change now, I don't think it'll be quite easy making that change when you're in year 12. I get some students that are in year 12 that have this problem, and sometimes it's just way too late, and it's really hard to get out of that cycle of just memorizing everything. So let's actually get on with what I'm trying to say. So, as you all know, that Pythagoras theorem looks like this. So in a triangle where it's right angles on the bottom, and we label the sides as so, okay, the addition of the square of the two sides that are not the hypotenuse, so in this case A and B, okay, is equal to the square of the hypotenuse. Notice that this is always the hypotenuse, and two other sides are the two shorter sides of the right angle triangles. Okay, so if we want to just find out that c on its own, not c squared, what we do is we square both sides. So c is equal to the square root of a squared plus b squared. Okay, and you'd probably already see the alarming similarity between this formula and this formula, in that d looks kind of like a c, and that x2 minus x1 squared looks kind of like a squared, and y2 minus y1 kind of looks like b squared. Okay, so with that in mind, let's actually turn to an example that we can actually use. Okay, I'm going to choose a color there. So we've got the line that joins the 2 points A and B at their respective coordinates 2, 2 and 5, 4. So and you have to see that we actually can form a triangle out of the line that joins them too. And this is the beauty of coordinate geometry, really. So as you can see that we can form a triangle like so, where the 90 degrees is down here. Okay. We can easily say that that's the base length, which kind of is in conjunction with this side over here where my mouse is pointing, and this side over here is in conjunction with that side over here. So if we know the distance of this and this, the horizontal length and the vertical length, then finding the hypotenuse, hence the distance, is going to be easy. Okay, so that is represented by the horizontal distance between A and B, and that's 3. How do we know that? Because, well, we can kind of count up the squares, can't we? 1, 2, 3. And from here to here, we know that the distance is 2. Okay, we can likewise count up the squares. But what happens in a case where we aren't able to count up the squares, in that the coordinates can be decimal or can be really, really big, so that we can't actually have time to sit down and literally count up those squares? The answer is quite simple, because, you know, if you understood, you know, this bit here, then it's quite easy that the horizontal distance can be represented by the differences in the x coordinates of A and B, isn't it? So we've got the x coordinate of B, which is 5, and the x coordinate of A, which is 2. So if we subtract the 2 from 5, then we're going to know that the horizontal distance between them is going to be 3. Likewise, the vertical distance can be subtracted with each other in order to find the actual vertical distance, can't we? So we can subtract the 2 away from that 4 up there. Okay, and once we have that, it becomes quite easy. You just square the 3, square the 2, add them together, square root it, and bam, we've got the distance. Okay, so what does that look like? It's just, I will write that out if you didn't catch it. So we just go 3 squared plus 2 squared, and then square root that, and then we get our D. Okay, so that's this thing that we're doing over here. So in that, our A is at 3 there, and our B is at 2 over there, and our C is our D over there. Okay, all right, so I mean, that works for this case, but how do we generate this formula here? But, you know, I've already kind of mentioned it, haven't I? So the difference between the 2x coordinates of the 2 points and the difference between the 2 y coordinates, we get the, you know, the height of the triangle, and that's the base of the triangle. Square it, add it, square root it, and bam, we get our hypotenuse. So that D is in effect the hypotenuse, which we know as the distance between the 2 points, isn't it? So in math, this is how you really should be understanding your concepts. If you don't do this, I mean, like, I will introduce more and more coordinate geometry theories, but you will realize that there really is no end to memorizing. So don't do that. Just you know, give it an end now. And start understanding things out of what you already know. Okay, so Pythagoras theorem is something that we already know. This formula, the distance formula, shouldn't be something that we learn as a new kind of a thing. Okay, this shouldn't be new to you. Once you know the Pythagoras theorem, then you should apply your knowledge of your Pythagoras theorem into that distance formula. And I've just shown you how it exactly worked with a little diagram as well. Okay, so please, you have to be able to know how to do this. And in the test, you don't want to be remembering formulas, but generating them. And that's how good you should be at math. Okay, and trust me, you will be good at it if you start practicing this now. Okay, so I hope you guys enjoyed that, and I will be introducing more stuff from coordinate geometry. Please keep watching my videos, and yeah, keep me posted on any feedback or comments. Thanks, guys. That was HD Academy. My name was Hando, Elite Tutor. Bye bye.